Good morning, everyone. I want to thank Alibaba Cloud for inviting me. And for those of you who aren't familiar with what an industry analyst does, that's me, I'm going to go through that a little bit just so you understand the perspective that I'm coming from. So I'm at Forrester Research, and we have global clients, the largest enterprises in the world. And I cover two main research topics, AI and what we call streaming data platforms, sometimes known as data streaming platforms. So what I do is I'm constantly talking to our clients. They have questions about real-time processing, about AI platforms, about AI infrastructure, these topics that I cover. So I'm constantly hearing from them what they're interested in and what their maturity level is at. But I'm also talking to the vendors, and I'm also evaluating products in the market. And I've been covering streaming data platforms for 17 years. And you might be thinking, oh, did they even have them 17 years ago? Well, actually, my first coverage of this was something called CEP, or complex event processing. And this was stateful analytics way back when financial services firms were looking for patterns in data, either for market surveillance or for algorithmic trading. And I also cover some of the practices as well. So the people I'm talking to are usually the tech leaders and the business leaders. So what I wanted to do this morning is to give you the business perspective of why the need for streaming data platforms is so great and why it's going to expand and get even bigger. And whenever we do the research, we take what is the backdrop of that, what is really the key challenge. And the key challenge in most things, right, is time, and the time that's necessary to do that. And from a data standpoint, all data originates in real time. And my clients are reminding me of that, and I remind them of that when they don't mention it, because we all think of data as maybe it's living in a data lake, or it's living in a data warehouse, or it's living in a database, but it always originated in an instant somewhere else, right? And the trend that's been happening since Flink was conceived and other streaming projects is that data, that time, people want to take advantage of that time, right? And that's why 17 years ago, when I started covering this in CEP, complex event processing, financial services industries were sort of the first to try to take advantage of this. And now almost every industry is trying to take advantage of this. And they're trying to get insights from that. They're trying to get events. And the insights that they glean from that is perishable. So at Forrester, we came up with a way we called the perishable insights. We came up with a way for business people to think about the importance of the timing of that data and the origination of that real-time data. So as you can see on this slide, the data originates. There's some analytics performed on it. Perhaps an inferencing is performed on it. But if it goes under this line, we have outdated insights, or we have an outdated answer. So if you're asking an LLM some question about some past or something, just some fact or some piece of knowledge, okay, you'll probably get the answer. But if you're asking some supply chain question that impacts the entire supply chain right now, right, you need that answer because you need to make a decision. So we call this perishable insights. So the time to decide is shrinking. Oh, Mike, that's brilliant. It has been shrinking for years. But then if you start to think about AI agents, which I'm getting to, right, and you start to think of agents and how many decisions they're going to make and how quickly they're capable of making it, well, then this time to decide is shrinking even more and at a different scale. And when I say scale, I'm talking about miniaturization, right? So enterprises have invested in data for years. I mean, it's really the first use case for computers, right? And most of that investment occurred in this middle part, this what we call operational insights and performance insights, right? They wanted operational insights to see how they can improve, but not like right now. They wanted performance insights to see how the strategies were working, and so they invest in analytics and data warehouses. But what we've seen in the last few years is a focus now on investing in the real-time insights. And that's why platforms such as Flink have grown. And you can see some examples here of the actual business use cases and some that are strategic and the ones that aren't strategic, but the ones that are real-time, right? But there's also a feedback loop here. So the point of this is that enterprises have invested in this middle part, the data lakes. And I'm not saying these things aren't relevant, they still are, but where they haven't invested and where there's going to be a huge amount of investment, and I'll get to some projections on what that investment will look like later, is on this real time. And that's why you're all here. And this is what you're all interested in. So, but those insights without action are just insights. So, and this is also something that companies have focused on analytics. But when you start to think about the impact on automated agents, again, the time and the scale of this increases dramatically. So you have all of the same business use cases, but at a different level of scale, a different level of information, the telemetry and the data that you need, and the learning that has to take place in parallel. And that's where the unification of real-time and batch comes in. AI is going to be assigning carriers in real time. AI is going to be deciding how to keep customers, how to prevent those customers from churning. AI is going to decide within a few milliseconds, in some cases, like because you don't have too many milliseconds left over on a credit card transaction, whether something's likely to be fraud. AI is going to be monitoring all of the machines and making decisions right now about when to push the machines or when to pull back and maintain those machines. And AI is going to be making all kinds of financial decisions, navigating regulatory requirements. It's going to be controlling production, agricultural production. I mean, it largely is, but not at the level of agents. So my assertion to you is that when we start thinking about agents, it's not just more AI, but it's a fundamentally different AI that's going to need a real-time platform. Otherwise, it's not going to succeed at scale. So things like offering discounts that are hyper-personalized, different scale with different agents, different level of hyper-personalization. And if you take IoT use cases, routing traffic, for example, different scale, different latency necessary. So AI is going to be controlling all of this, but there's different types of AI. And the AI I've talked to you about is Agentic AI. And Agentic AI is not just about a person. There's two types of Agentic AI. There's the AI about a person sort of prompting and getting tasks done. That's great, and that's huge, and that will be very big. But then there's also the automated, the event-driven AI, where an insurance claim comes in, and an agent picks it up, and then it's going to have state. It's going to have to maintain state as it deals with other agents and other tools and agents outside of the organization to process that claim. So we believe there's going to be millions of these AI agents automating processes in enterprises and assisting billions of people. It's already happening. But what enterprises are not prepared for is using these agents within their legacy architectures. Because if you take any large bank, that bank grew through acquisitions. Maybe it made 20 acquisitions. And it has a very complicated enterprise architecture with all of these applications and all of that real-time data that originates in real time. So there's going to need to be some sort of real-time layer for these agents to operate. Is Salesforce Agentforce that layer? No. I mean, it is maybe within their domain, but within all of these enterprise systems, and especially the ones that differentiate, they're going to have to build bespoke applications and a bespoke enterprise agentic architecture. And that's going to lead all of these companies to be incredibly efficient, incredibly flexible. You're going to go from having 200 claims processors down to 10. And AI is software, and we've already used software to automate, and agents are the next step. And then if we even go beyond that and think of artificial general intelligence, right? The 4 characteristics of AGI, or artificial, is that it's going to self-learn, right? Whenever we get a new model, they trained it on this big data set. And yes, there are some continuous learning models. Flink actually can do some continuous learning of predictive models, right? But it's going to learn on its own. It's going to seek out knowledge. It's going to be able to collaborate with other AGIs and people, just like Agentic is going to be able to do, right? But this is going to do it more autonomously. And it's going to be able to act in both the physical and digital worlds, but it's also, maybe very uniquely, characteristically, it's going to be able to build its own tools. So when I think of that real-time layer, and I think of building those tools, what platform is it going to use to build its real-time nervous system? And I was thinking, would AI actually use Flink to build the real-time nervous system that it needs to be smart, right? Because it's not good enough to have a brain. You have to have everything else, all of the sensories. So these AI agents, let's go from AGI back to the agents. So these AI agents cannot operate. We're not going to have millions of agents automating the world at light speed unless it has that pulse of the enterprise. So it needs connectivity to legacy. It needs connectivity externally. It needs an ability to process that information. The AI essentially has to be able to think in real time, and to think in real time, it has to have access to that real-time data. So I don't design Flink. Some of you design Flink. Many of you use Flink and make suggestions. And you probably think about it. You think, oh, OK, well, we'd like this, we'd like that, we'd like this. And it's probably like for your own use. But what if you thought about, what if AI needed this platform? How should we design this for AI and agentic AI? So that could be a very interesting question. So I asked that question based upon the research that we've been doing with all of these enterprises. I didn't ask it of AI. This is based upon our research with the enterprises. The list is a little bit shorter than I would like, given the time frame we have here. But these are the 7 things to think about, which you already have thought about, the Flink community has thought about, the Flink community has used for years. But now we really have to think about them in light of AI. And the first one is data connectivity and abstraction. Because that agentic layer and those agents, they're going to need an abstraction layer. They're going to need an event-driven architect, or they're going to at least need to be able to process events, right? They have to have some way of knowing what's happening in the world. They have to have some way of knowing that they need to reschedule a carrier, or that a claim came in and they have to process that claim. So this goes way beyond just connectivity, but to an abstraction layer that identifies events and even the business objects themselves. So it's going to need to have that level of abstraction if you're ever going to build at scale a series of thousands of enterprise agents. Oh yeah, sure, you can build a few just by bringing in some data here and there, but then enterprise projects are going to stall because that's not a scalable architecture. You're going to have these business object models. The second thing those agents are going to need is it is going to need to be real time. because that's when events happen. That's when customers ask for things. That's when employees initiate things. That's when machines initiate things. That's when agents initiate things for other agents. So it has to be real time, but it has to be real time at scale, which includes concurrency, and in some cases, ultra low latency. And of course, it has to do it cost effectively as well, right? Because when you start adding LLMs and different mixes of LLMs, and you start adding state, those costs can increase. So you need AI, you need infrastructure that supports that, but you also need the software platform like Flink that can accommodate that. The other thing AI is going to have to do is, yes, it needs the real-time raw data, but sometimes the real-time raw data doesn't tell you the entire story. It doesn't show you a pattern. It doesn't show you that when one financial instrument, when the price goes down and another one goes up, that there's an opportunity within some time frame, some few second time frame. So it has to have some sort of stateful analytics and processing, which Flink has. But if I think about AGI and its need to build tools, or even agents, those agents are also probably going to have to specify what analytics it needs to get the job done, right? If you think about feature engineering and more statistical AI, a similar thing would happen in agents. So you need an incredibly stateful platform that can also find those patterns in real time that the agents are going to need to make decisions or move to the next step of the process. Another thing that Flink had built in, this notion of stateful analytics. And because you're going to have all of these agents, you need massive scalability of those agents, but cost effectively. So auto-scaling, all kinds of fancy automated features for doing that scaling, which is one of the things that's an evaluation point when I evaluate these platforms. It gets complicated because now you have agents, now you have state, and you have LLMs. So now you have all of these different processes that all have to scale separately, or at least they have to scale separately if it's going to be cost effective. And any of you who actually work on this stuff probably appreciate how difficult it is to do that. And it's also going to need to be fault tolerant, because unlike other data platforms, a warehouse, or just a data lake that's not serving applications, this is operational. This is the company running. So it has to have that, the type of reliability that operational applications will have, not the type of reality that people come to expect with data and analytics applications. And I love to call this fault tolerance because it's not uptime. It's not 5 nines or 6 nines or 7 nines or however many nines is required, but rather it's when something does fail. And it's not just at the infrastructure level, it's at the software layer. So can you support, do you have a requirement for 0 data loss? Well, yeah, you do. If you're maintaining state for an agent, right, you would have to maintain that 0 data loss. So again, this is another requirement of agentic AI that it's going to need. And then it's also going to need to have all of the governance, security, and compliance features that enterprises have, yes, because they're mandated to have it by regulatory authorities, but processes that they want themselves because they need to be able to manage their process. They need some level of reliability. But it's much more complicated with AI because the deployment mode of agents is not going to just be, okay, here's the next version of the agent, we deploy it. Because any of you who now operate with machine learning models to make predictions, I bet that's not how you do it. I bet you A/B test models. You probably have, you might have, multiple models concurrently running in production. And that's a risk management strategy, right? So now imagine if you have multiple versions of agents running in production simultaneously. I assert that companies will have to for many processes because they won't be able to tolerate the risk, and they won't be able to have the level of testing that they need to be 100% confident that they can deploy that next version of the agent. But the agent isn't just this transformation of some input data to a prediction, like a regular old machine learning model. It has much broader implications because it's going to be taking actions. It's going to be collaborating with other agents. So that governance, security, and compliance piece for agents, much more complicated. But it's going to need that. And of course, it's going to need also the ability to adapt. It's going to have to be open to other types of software, especially other open source projects. One of the things that I love that's finally happening, I mean, it's been happening, is all of the open source models, right? Because when OpenAI came out with ChatGPT, OpenAI was positioning itself as the only solution. That's probably not good for enterprises. And it's clearly not true anymore. But there's a very vibrant, as you know, open source community in models, the frameworks. And the next stage is platforms like Flink to be able to support agents, not just inferencing, but agents as well, and to be open and extensible to other open source projects. So what I've seen in the last year is I've seen open source. Okay, so the way the analyst business works is that we have all of these clients and they ask questions. And when you start to get a wave of questions, then you say, I'm getting a wave of questions. I better write some research about this. So 6 months ago, we started getting a wave of questions about open source AI. And so I published one document on it a month ago. I have another document coming out on open source AI in about a month because there's a wave of interest in this. So enterprises have realized, they already knew that they have an extraordinarily complex environment and that, yeah, they just can't, in all circumstances, buy something off the shelf to do this. So they realize they're going to have to build and support an agentic architecture that's event-driven, that handles real-time data, that unifies real-time and batch, that does many of the things that Flink already does and some of the things that it's about to do. So that has brought on a wave of interest from these enterprises in open source, and that's going to bring another wave of interest in platforms such as Flink, even more so than it already is. So I think these 7 requirements match perfectly to the origins of Flink, like by design, even before we had agentic AI, but also what agentic AI actually needs in a central nervous system, because that brain of the agent is going to be only, well, it's still, okay, isn't it still true? It's always true that garbage in, garbage out is, you know, what developers have been saying for, I don't know, since there were developers, I guess. So Flink meets those central requirements for AI data processing engine, right? It's both real time, but it can also do the batch that's necessary for prepping for learning. I actually think that there's some sessions this afternoon about continuous learning with Flink in large batch processes, but that also process real time. But it's not enough for the architecture, and that's where the open source community sort of steps in, or has steps in, or always steps in. It's just part of how open source works, with additional adjacent products. And I just listed, probably some of the most important ones, or some of the ones that are most relevant to Flink here: Pymon, Kafka, Iceberg. There's others. I saw we had Flus up there, and there'll be more projects to this. So the good news is that enterprises are thinking about open source and AI, and they're thinking about this new architectural layer, this real-time, event-driven, agentic architectural layer that they're going to need to roll out. And this is as big as when they thought of service-oriented architectures, well, even before that, web architectures, service-oriented architectures, microservices architectures. So this is the next wave of that to empower and enable these agents. So at Forrester, we call these streaming data platforms, also known as data streaming platforms. And our formal definition of this is, I guess I can read it. Streaming data platforms, enterprise software, it ingests from multiple disparate live streaming sources. And it messages that data. So we expanded this to include like connectivity and messaging, because you have to get data in and out. Real-time insights, which must be stateful to detect patterns, right? Otherwise, it's just a piece of data that you're evaluating against some condition. Yes, that's real time, but it's not sophisticated real time. And then also to run arbitrary real-time workflows in the background as well that are needed for real-time as well, or for downstream repositories or applications, right? Those might be connections to something like Pymon or other things even. So when we look at this market, we estimate in 2025 that it's about a $35 billion market. Now you see the technologies on the top. That's kind of important because it's not just one thing. It's a few categories. I did a very formal forecast of this several years ago, and it's very difficult to do because there's pieces of this market. Some vendors have pieces, some have all. The hyperscalers, the cloud vendors, Alibaba has all of these components, right? But sometimes it's hard to slice them together. But our best estimate is that for these categories, it's about $35 billion with a 27% growth rate. But we revised this because we think agentic AI will actually amplify the need for this, right? And that's why I was telling you, I think this is a wave just like web architectures, just like SOA, just like microservices. Perhaps just like big data, but no, it's not like big data. You know why? Because this isn't really an analytics platform. The need here is for a platform that is operational, serving agentic AI. So we think this, I think we estimated it would be about 11% more than an original estimate, and that would bring that significantly higher. I think it could be a lot higher, but I don't think it will, because the AI platforms, which I also cover, right, they have a very simplified view of what it means to connect to data, and they have very loud voices in the market, because when people want to buy AI, they go, oh, here's an AI platform company. And what is the AI platform company? Oh, yes, we connect to all of these data sources. Oh, yes, we can use data there. We can use data here. So they give the buyer a naive view of the reality of what's actually necessary because they don't have it per se. So that tends to slow things down a bit in terms of enterprises thinking about this and adopting it. The good news is that within an enterprise, the buying center for things like anything related with data was in a data organization and often even in a data science organization, but that's now shifted to enterprise architects, chief technology officers, office of the CIO, and they're much more application focused. So there might be a little bit of a lag to make this growth rate even higher, but nevertheless, we think it'll be significant as more companies think about open source and think about enabling an agentic architecture. So what I'm reminding enterprises, because remember I cover AI platforms, so they're asking me about AI platforms, I remind them that they can do a pilot or a little project, but they're not going to scale this out unless they have this real-time central nervous system, that all data originates in real time. Don't think it doesn't, because it does. And the need for it is amplified by agentic, because AI has to think in real time. So enterprises have to invest in a streaming data platform that has all of these capabilities, because they have to build a bespoke architecture to work on their bespoke legacy architecture if they're going to become agent-enabled. And the people who are building that and the people who are closest to being able to satisfy that enterprise need, the people using Flink, the people creating Flink, the contributors, and the companies that are creating Flink. Because that AI, that brain, cannot work without a central nervous system, and you're the ones building it. Thank you.